Hello students. So here I have drawn a Carnot cycle operating between the temperature limits TH and TL. Okay. So this Carnot cycle, that means it's a reversible cycle. So I will write this W as WR, that is net work output during a reversible cycle. Now please recollect that we have already derived Clausius theorem. What does it say? Clausius theorem says that integration of dq by t for a reversible process is 0, right? Integration of dq by t for a reversible cycle is cyclic integral. So dq by t for a reversible cycle is 0. This is Clausius theorem. Now this is also reversible cycle. Now let's say you know that efficiency of this is given by QH minus QL upon QH, right? And this is also equal to, because this is reversible cycle, this is also equal to TH minus TL upon TH, right? And from this we have already done, just rearrange, we get this as QH by TH. QH by TH is equal to QL by TL. Sorry. QL by TL. Okay? QL by TL. Now, when we take QL on the left hand side, this will be QH upon TH minus QL upon TL is equal to 0. Okay, so this is something which we have done, right, from here to here and this. Now see, this is nothing but this, right, because this is basically it is heat transfer upon the temperature at which heat is being transferred. If you have that during a entire reversible cycle, that ratio, if you algebraically add it, it's going to be 0, and this is what is dq by t is equal to 0. So this same thing is essentially is equal to cyclic integral of dq by t. What is dq? So this is our engine to which heat is added, right, and it's added reversibly, and there is a temperature at which engine receives the heat. Please note that this is TH, the source temperature. The engine temperature will also be equal to TH, right? One can say TH minus say dTH, right? And where dTH tends to 0. Why? Because the heat transfer is reversible. That means it is across infinitesimal temperature difference. So this TH is tending to 0. You can remove it. So this is across, in fact, temperature here is TH, here also it is TH. Here, when heat is rejected, this temperature of the engine, one can say it is TL plus dTL, right? This is because I'm so sorry here, this should have been TL, right? I'm so sorry, it is TL. So this is TL, is the sink temperature. The engine rejects the heat, and heat rejection is reversible. So the engine temperature will be slightly more than this, infinitesimally higher than this. So this is TL plus dTL is the engine temperature, where dTL tends to 0, right? That tends to 0. So this is the reversible heat transfer. This you know, right? So during this cycle there is heat addition, heat rejection, and if you add dq by t, taking algebraic signs, this is QH upon TH minus QL by TL, that will be equal to 0. This is Clausius theorem, right? For a reversible cycle, dq by t is 0. This is essentially Clausius theorem. Now let's say that this cycle, now consider this as a irreversible cycle. Now you know that reversible cycle is a theoretical cycle. It's not a reality. But irreversible cycle is a reality. Okay, irreversible cycle is a reality. So let's say that this cycle now is irreversible. Meaning what? Just think about it. Meaning now we have please recollect the Carnot theorem. In Carnot theorem we said that of all the engines operating between the same temperature limits, the efficiency of the no engine will have efficiency greater than the Carnot engine, which is running between the same temperature limits. So this is reversible engine, that means it is Carnot engine, right? So any other engine, that means if you have any other irreversible engine working between the same temperature limits, its efficiency will be less than this. Its efficiency is less than this. So let's consider temperature limits are same, but this is a irreversible engine. So what does it mean? Let's see here. Suppose I am considering this as irreversible engine, so I'll write here I, just to denote this is irreversible engine. Now see, irreversible engine operating between the same temperature limit, if same amount of heat is transferred, now the work output will be different, right? That means let's say it won't be WR but WI, that means for a work output of an irreversible engine. Obviously this WI will be less than WR. Why? Because this is an irreversible engine operating between the same temperature limits. Its efficiency has to be less than the reversible engine, and both the engines are supplied with QH. This engine will produce less work than the previous. So WI is less than WR, right? WI is less than WR. If WI is less than WR, that means less work is output, more heat has to be rejected. Obvious, right? More heat will be rejected. So let's say this is QL dash, right? This is a heat rejected in irreversible engine. Earlier was QL. Obviously, because less work output is there, more of heat has to be rejected. So we can say that QL dash, which is heat rejected in a irreversible engine, will be less than QL. QL is heat rejected in a reversible engine. Okay, if this is clear to you, now just pay attention to this. This is what we had written. I'll rewrite it here. So for a reversible engine, we had written QH upon TH minus QL upon TL is equal to 0, right? Now suppose this engine, now we are considering it to be irreversible. That means what? Now TH, TL are same, QH is also same. What about QL dash? Now this, if you write the same expression for irreversible engine, we can say it is QH by TH, right, minus QL dash by TL, right? QL dash by TL. QL dash, please note. Now see, QL dash is less than QL, right? Look at this. QH upon TH minus QL upon TL is equal to 0. If you are substituting QL by QL dash, that means this value diminishes, right? I'm sorry. QL dash is I'm terribly sorry here. I need to QL dash. I'm so sorry. QL dash is greater than QL because more heat has to be rejected. Please correct it. QL dash is greater than QL. More heat has to be rejected because in irreversible engine less work will be produced, so more heat has to be rejected. So QL dash is greater than QL. Now see here, QH upon TH minus QL upon TL is equal to 0, right? Now if in place of QL for irreversible engine, if you consider QL dash, that means this term is more than QL, right? If this term is more than QL, obviously this expression will be less than 0, right? Will be less than 0 because if this is equal to 0, then if you are substituting QL by QL dash, which is greater than QL, right? So now obviously if this is equal to 0, if you are subtracting more than QL, obviously this will be less than 0. So this expression is for irreversible cycle, this is for reversible cycle. Okay, so that means cyclic integral of dq by t is equal to 0 is for reversible cycle, but for irreversible cycle it is less than 0, right? That means for this I can write cyclic integral of dq by t for a irreversible cycle is less than 0. So for a reversible cycle, this is the expression. For irreversible cycle, this is the expression. If I combine this, then we get this expression. dq by t is less than or equal to 0 for a cyclic process, equal to 0 for a reversible process, for a reversible cycle, less than 0 for a reversible, less than 0 is for a irreversible cycle, equal to 0 for a reversible cycle. Okay, so this is, and what if it is greater than 0? If in a numerical you come across, you are given a cycle, then you do the integration, etc. We'll see how we are going to do that. But if you say cyclic integral of dq by t, you get greater than 0. What does it mean? Just pay attention here. What was this? Essentially, this is qh upon th minus ql upon tl was equal to 0. This is for a reversible cycle. Now, when you say this is greater than 0, right? Under which circumstances this is going to be greater than 0? Just think about it. Under which circumstances this is going to, if here both these terms are equal, right? And if under which circumstances this is going to be greater than 0? I want you to think it hard, right? Look at this here. If you consider this as a reversible cycle, okay. This is reversible, this is reversible, okay. For a reversible cycle, this is equal to 0. Under which situation this will be greater than 0, right? This will be greater than 0. Just think about it, and I want answer, because I want you to think hard. This will be greater than 0 only if you violate second law, right? Only if you violate second law, this is going to be greater than 0. Just think about it, and I'll explain that in the next video. Thank you.